So this is an algebra video, not a trig video. I guess my class is doing okay, but I mean it's not the greatest. So I wanted to try and help you guys. And basically in this video, I know this when I upload this, it'll be way too late for you guys to study for the upcoming test tomorrow, but you can use this as a study tool whenever you want. Basically, what I'm going to be doing is going over the entire quiz all over again. So all 5 or 6 questions, I believe. Maybe it was 6. So, yeah, that's what I'm going to be doing. So the first question says to factor completely 16a4 minus b4. This is, as you can see, a difference of 2 squares. It's a difference of 2 squares, so what I can do is I can just take the square root of both the a and the b terms and just stick a plus and then a minus in between both of them. So we're going to have the square root of 16a4. So that's 4 because the square root of 16 is 4, and the square root of a to the 4th is a to the 2nd, because a squared times a squared is just a to the 4th, right? Because a times a is a squared times a times a. It's just a times a times a times a. That's a to the 4th. And then plus b to the 2nd is the square root of b4. Same reason as why square root of a to the 4th is a squared. And then you do the same thing, but just stick a minus sign. So most people would be done here, but this actually isn't factored completely because we have this thing right here that's still a difference of 2 squares. It's still a dots that we need to factor. So we actually just bring this down the way it is. So 4a squared plus b squared. You can't do anything to sums, but here you can take the dots again. 2a plus b, 2a minus b. Because the square root of a squared is just a, and the square root of 4 is 2. And yeah, that is how you would do the first problem. For the second problem, this problem is very, very involved, and there's so many ways you can go wrong here. So I'm going to try and explicate it as much as possible so it's easy to understand. So you have this divided by this c squared minus 4c plus 4 plus, and this big fat plus means that you can't simplify across that plus sign, 12 over c squared minus 4 times 2 minus c over 3. Well, first of all, we should factor everything as much as possible. So this 2c, we can't do anything with that, but this c squared minus 4, we can factor that into c plus 2, c minus 2. And this division sign means that we could flip this into multiplication, so that's exactly what we'll do. So what actually happens is when I do flip it, which I'm going to try and do right now, when I flip into a multiplication sign, this thing is actually flipped to the reciprocal, which means that it's actually going to be c squared minus 4c plus 4 over 4. So that's the keep, change, flip that you have to remember. And now we should factor this top half, right? So how do you factor c squared minus 4c plus 4? Well, c minus 2, c minus 2, right? Because it's kind of an art. Factoring is an art. You either get it or you don't, and with practice, but only through practice can you really get good at it. And it's about seeing these things, which is important, because minus 2 is minus 4. Minus 2 times negative 2 is equal to positive 4, so it matches up. So our numbers, our factors are going to be c minus 2 squared, or just c minus 2 times c minus 2. And then all of that over 4. Now let's do the other half. This big flat plus means that we can't bypass that. So what can we do here? 12 over what? Well, c plus 2, c minus 2. Whoops, c minus 2 times 2 minus c over 3. Well, now let's simplify from both halves of the big fat plus sign, which I will do in purple. So this 2c goes away, so I'm going to use my expertise eraser to erase that away. So that 2 goes away, this 4 goes away, and in its place is a 2, right? Because we canceled out the 2 and the 4. This c minus 2, well, what did I do here? This is a c minus 2, c plus 2. So what is going to happen is that we have this c minus 2 canceling with this c minus 2. And that's all we can do here. So what are we left with? If we erase the c minus 2's here, which I will do, and if I erase that c minus 2 here, what are we left with? We just multiply across, right? So that's going to be c times c minus 2 over 2 times c plus 2. Now we have that big fat plus sign. And now let's see what we can cancel here. Well, this thing cancels to 4, and that's 1. And this c minus 2 and this 2 minus c, they look similar, right? Because they're just flipped with that subtraction sign. This thing actually cancels to -1. So now what are we left with? So if we erase, again, if we erase that, we erase all that, and we erase this, and we erase that, what are we left with? Well, if we just multiply across, we just get -4 over c plus 2. And subsequently from that, this thing is just the same as rewriting that minus sign over here, like that. So what is it really? A plus and then a minus combined to make a minus, right? So this thing just combines to make a minus. Right there. And I should actually make that in blue. Right. So now we're done with all the simplifying thing for now. But now we need to add these fractions. And how do we do that? We have to find a least common denominator. We have most of the work cut out for us here. So because to add or subtract fractions, we need a least common denominator to combine like terms, I should say. So we have most of the work cut out for us here. We have a 2 times a c plus 2, and then we already have a c plus 2 here. So we know that the least common denominator here, the LCM, is 2 times c plus 2. So what do we have to alter here is the question I'm asking, I guess. Well, this 2 times c plus 2, this is the LCM. We don't need to change that. So we can just leave that c times c plus 2 the way it is. But this fraction right here with the c plus 2, we need to multiply it by 2 so that it can be 2 times c plus 2, and it can be the least common denominator. And whatever we multiply to the denominator, we have to multiply to the numerator. So if we multiply this thing by 2 and this thing by 2, what are we going to end it with? Well, this fraction is just going to become 8 over 2 times c plus 2, right? So what are we actually left with? And I'll get rid of all this real estate over here so that it's easier for us to write down our problem. So what are we left with now? So we're left with a c times a c minus 2 minus 8 over all of that over 2 times c plus 2, because we just combined that denominator. So now what do? We have to expand this c times c plus minus 2, because I think we can still do something with this numerator here. I think we're on to something. So what we do is we multiply it out, and we get c squared minus 2c minus 8 over 2 times c plus 2. From that, we can factor this numerator into c, let's see, c plus 2 and c minus 4, right? 2 minus 4 is negative 2. 2 times negative 4 is negative 8. And on the bottom, we're left with all of that over 2 times c plus 2. And now, as you can see, we can actually cross out the c plus 2 and the c plus 2. So when we erase this, and once we erase that from the equation, what are we left with? Lo and behold, we have an unsimplifiable answer, c minus 4 over 2. That is a very involved problem. In my opinion, that question seemed a bit too hairy to have on a quiz, but, you know, it is honors, so you should expect questions like that on quizzes. But still, that was a very involved problem. I wouldn't expect anyone to fully get to that final answer. So now let's do number 3. Solve for x. X minus 2 over x is equal to 3 over x plus 2. Alright, well, we have one fraction on the left side, one fraction on the right side, so this is easy as cake. We can just cross multiply. So if we multiply this term by this term, and we multiply this term by this term, it should be a piece of cake. So what do we get? We get x minus 2 times x plus 2 is equal to 3 times x, which is just 3x. And when we multiply this out, we get x squared plus 2x minus 2x minus 4. And these just cancel out. So we're left with the difference of 2 squares, which you might have intuitively known already, but it's okay. You can use FOIL if you want. So we're left with x squared minus 4 is equal to 3x. What do we do here now? We should make this a factorable quadratic, right? So we can subtract this 3x and bring it over here. So we're left with x squared minus 3x minus 4 is equal to 0. Now if we factor this, we'll end up with x plus 1 times x minus 4, if I'm not mistaken. That's just some more factoring. And now when we tee up here, we make a table, and we set both values, x plus 1, whoops, wrong tool, is equal to 0, and x minus 4 equal to 0. We'll get x is negative 1, or x is positive 4. So your solution set for this was negative 1 and positive 4. That one was a piece of cake, or at least it should have been. Number 4 was pretty difficult, I'll have to say. But with a bit of, if you knew what you were doing, I guess you were fine. So it says write in simplest form, 1 plus 1 over y minus 6 over y squared over, all of that over, so it's a complex fraction, 1 plus 11 over y plus 24 over y squared. So what I'm going to do here is I'm going to multiply every single term in this fraction by y squared. What I mean by that is I'm going to multiply the numerator by y squared, and I'm going to multiply the denominator by y squared. What that's going to do, and this doesn't alter the fraction at all because y squared over y squared is just 1, right? So I'm just multiplying the fraction by 1 over 1, essentially. That's what I'm doing. What this is going to do is this is going to cancel out the smaller denominators of both complex numerators and denominators, and we're going to end up with a neat fraction for us to simplify. So when we distribute this y squared, so let me write this in another way. So we have a y squared times 1 plus 1 over y minus 6 over y squared is just another way of looking at it, over y squared times 1 plus 11 over y plus 21 over y squared. This is just another way of looking at it, what I'm doing here. This is equivalent to that. So what I do is, so we get y squared times 1 plus y squared times 1 over y plus, minus y squared times 6 over y squared. And then all of that over y squared times 1 plus y squared times 11 over y plus y squared times 24 over y squared. I'm just making it as clear as possible to show you how I'm distributing and what I'm exactly doing. So now what does this become? Let me just get rid of some of this space over here. So this is what we have. What can we do with this? Well, y squared times 1 is just y squared, right? So this is taken care of, right? And then the second one, this y cancels with this y squared to leave a y behind, because y squared can cancel with that y. So what we have is a y squared times 1 over y, and the same thing as that. This cancels with that, so now we have just a y over 1, which is just y, right? That I'm just showing you my extended thought process there. So what we have is just plus y there. Now here, the y squared and the y squared here just cancel out completely, so we're just left with a minus 6 here. So there's the numerator, and look how beautiful that is. That's just really simple and easy to factor and possibly simplify, right? So now the denominator here, y squared times 1 is just y squared, plus this power cancels with that, and we're just left with a y again, but we're multiplying that y by 11, so it's 11y. This y squared cancels with this y squared completely, and we're just left with a positive 24. So now we have this much more digestible fraction that we can actually simplify. So the numerator simplifies to y plus 3 times y minus 2 over y plus 3 times y plus 8 if you do your factoring. And now we can do simplification. We can cross out the y plus 3's, and we are simply left with y minus 2 over y plus 8 as our final answer. Phew, that one was pretty long. Number 5. Let's do number 5. Number 5 actually isn't too bad in my opinion. It says, solve for D. Hold on, let me just check to see if my audio is still going. Yep, it's still going strong. So yeah. Whoops, I accidentally touched my software there. Whoops. So it says solve for D. 1 over D plus 3 minus 2 over 3 minus D is equal to 4 over D squared minus 9. So let's see what we can do here. First of all, I don't like this D3 minus D here. It's abnormal. It stands in the way, and we know already that D minus 3 is equal to negative 1 times 3 minus D, right? Because what happens when you distribute this negative 1? You get a negative 3 plus D, and if you move that negative 3 over to the right side, we get D minus 3, right? So we know that D minus 3 is equal to negative 1 times 3 minus D. That's just a property, right? So we can rewrite this 3 minus D, and let me use my eraser here to rewrite this actually as negative 1 times 3 minus D. I mean, what am I even saying? What am I even saying? D minus 3. Because this was 3 minus D before. Ew. Okay, so what am I saying? This is true, but let's flip this a bit. 3 minus d is equal to negative 1 times d minus 3. Hopefully I didn't confuse anyone here. Basically what I'm saying is we can just flip that 3 minus d into a negative 1 times d minus 3, and you can see why in this top right corner. I hope I didn't confuse anyone there. So what can we do? We can bring this negative to the middle of the fraction. I'll show you what I mean there. 1 plus d minus 3 minus 2 over d minus 3. It doesn't matter if you have a negative anywhere in the fraction. You can just bring it to the back like that. Equals 4 over, let's just factor this. Why not? D plus 3, d minus 3. That is difference of two squares, right? And square root of 9 is 3, and that's why we have 3 there. So what happens when you have a minus? Well, two negatives make a positive. So these negatives actually combine to make a positive. So now we have a positive equation here. 1 over d plus 3 plus 2 over d minus 3 equals that. So what can we do here? Well, I don't like working with these fractions, so what I'm actually going to do is I'm just going to eventually cancel out the entire denominator from the equation itself. So we're only left with non-fractional numerators. And how do we do that? If all the denominators in an equation have the same denominator, we can just cancel that out. So if we had an equation like 3 fifths plus x fifths x over 5 is equal to 4 over 5, like that, we could just cancel out all these 5s and just be left with 3 plus x is 4, and, well, obviously x would be 1 there. But that's just an example to show you. And of course, if you plugged 1 back into that equation, it would work. So that's kind of like an inductive proof, I guess, to prove that this works. You can just cancel out the denominator in an equation if everything's the same. Only in an equation, though. Only when you're dealing with equations, not expressions. Definitely not expressions. So we have to find an LCD here, and I think it's pretty evident that d plus 3 times d minus 3 is the least common denominator here. So what we have to do is we have to make every fraction the least common denominator. How do we do that? Well, let's see. D plus 3. For the first fraction, we already have a d plus 3. So what can we multiply this d plus 3 to get d plus 3 times d minus 3? Well, that's just d minus 3, right? If we multiply d minus 3 to d plus 3, we get d plus 3 times d minus 3. So what we're going to do is we're going to have the d minus 3. We're going to multiply this both by a d minus 3 over d minus 3. Note that I'm not altering this equation in any way because basically I'm just multiplying by 1. See? D minus 3 over d minus 3 is just 1. So now we have that big fat plus, right? So now back to black. What do I multiply d minus 3 with to get d minus 3 d plus 3? Well, that's just d plus 3. So we have a 2 over d minus 3. We're going to multiply a d plus 3 over d plus 3 like so. Now we get a big equal sign, and this thing, we don't have to even change this because the denominator already is the LCD. We don't need to change anything. I mean, you could do something like that just to show that we're multiplying it by something, but we don't need to. So now what does this become? This becomes, if we just multiply straight across, note the plus sign. We can't do anything across that big fat plus sign. Multiplying across, 1 times d minus 3 is just d minus 3 over d plus 3 times d minus 3. Big fat plus sign over there. 2 times d plus 3 is 2d plus 6, because 2 times d plus 3, distributed out, you get 2d plus 6, right? So you get d plus 3 times d minus 3 in the denominator, and that big fat equal sign is 4 over d plus 3 d minus 3. Pretty massive numerator, but look what happens. We can just cross all that out right there. Boom, magic. And now we're only left with the numerator. So what is that numerator? That numerator is just d minus 3 plus 2d plus 6 is equal to 4. And this is just a piece of cake now. We can just combine like terms and get 3d plus 3 is 4. 3d is 1. D is equal to 1/3. So that was also a lengthy problem. I really don't have any comments as to whether or not these questions should have been on the quiz. I mean, it's an honors class, so I would expect I don't have any complaints. If it was a Regents class, I would say that this is a bit of an unfair quiz, but you know, we like to challenge ourselves here, don't we? So the final thing here, I'm just gonna kind of rush it because I'm nearing the 30-minute mark, and if you're still watching this and you haven't skipped around, congratulations. So number 6 says solving graph x squared minus 2x minus 15 over x minus 2 is less than 0. What do we get here? So first of all, we need to switch this to an equation, right? So this becomes x minus 2 is equal to 0, and if we factor, we get x plus 3 times x minus 5 over x plus 2 is equal to 0. If we cross multiply here, I guess we could say we're cross multiplying, right? So if we cross multiply, 0 times x minus 2 is just going to be 0, so we can just cross that out from the equation entirely, and we're just left with x plus 3 times x minus 5 is equal to 1. Wait, what am I doing this right? Oh wait, no. What am I doing? So 1 times x plus 3 times x minus 5 is x plus 3 times x minus 5, and x minus 2 times 0 is just 0, right? Like that. So when we tee up, sorry, I hope I didn't confuse anybody like that. I confused myself for a second there. So x plus 3 is equal to 0, x minus 5 is equal to 0. So x is equal to negative 3, and x is equal to positive 5. That x actually isn't equal to negative 3 or positive 5. Those are just what we call the critical points. Critical points. And critical points are whatever x, the roots of x are, which is what we just solved for, or, well, not or, and the values that make x undefined. Those are going to be our critical points that we have to test for these rational inequalities. And over here we can see that x minus 2, when we set that equal to 0 and x is equal to 2, we know that 2 is also a critical point. Why? Because x cannot be 2. Then this entire inequality would be undefined. So now we have our critical points. So our points are going to be, CPs are going to be negative 3, comma 2, comma 5. So if we erase all this and we make a big number line now, we now know our critical points. We can just make a number line now. A number line. Negative 3, 2, 5. We have to test actually 4 sections. One for one section here, one section here, one section here, one section here. We need to set up 4 different test points, and that can be a pain, but it's not that bad. You just need to plug in four numbers and see if the equation given, which was x squared minus 2x minus 15 over x minus 2 less than 0, is true or false. And I'll save you the time and effort here and just tell you that this first section was true, so that's what I'm going to do. I'm going to graph less than negative 3, and these are all open circles because the inequality stated not less than or equal to, it was just less than, and of course the critical point would always be open, because if it was closed, then that would make the inequality undefined, right? So the critical point for the values that are undefined, they're always going to be open. Be sure to know that. So 2 was false, so we don't graph anything. 3 was true, so we're going to shade that in, the interval from 2 to 5. And 4 was false, so we just leave that blank. So what are we left with? The solution set for x is less than -3, or, keyword or here, 2 is less than x is less than 5. And that is going to be your solution right there. And there you have it. That is all 6 test questions done in exactly, well, almost exactly 30 minutes. Whew. So I hope you guys appreciated that. And next time I might do more review videos like this.